here is set. And now we're going to look at exercise 6. So last time we started to solve systems of equations. And I guess this exercise is nicely designed for elimination of y's when you add the two equations together. So if I add these equations, I'm going to have 2x on the left side, x with x, equal sign, and 2 plus 4 will be 6. So that would be our equation that we can find x from, and x will be 3. 2 times 3 is 6, right? X is 3. So I can use, let's say, first equation. We know it doesn't matter first or second. So if I use first equation, 3 plus y equals 2. And it looks like y should be 1 because 3 plus 1 is 2. So the answer is a pair. X is 3, y is 1. So that was quiz from last time. And these two equations are just designed for elimination because you can very nicely subtract one from the other. So today I'd like to solve more of these equations, and let me do problem number 13 here. 13. That actually solves system by using the other method, so-called substitution method. I would say that's pretty rare, but this example illustrates why sometimes you want to substitute or plug in my first equation instead of y 3x. It's convenient because looks like y is nicely isolated on the left side of my second equation. And when I replace that y with 3x in the first equation, please notice you don't really have to do any eliminations, but just to get y replaced with x. So you end up with 4x is equal to 4 and x equals to 1. So sometimes when you have one of the unknowns already isolated on one side, well, you can use this alternative approach, so-called method of substitution. And after you've done that substitution, then you can use this substitution to find y, because y is conveniently isolated already. So it's 3 times x or 3 times 1. So y is equal to 3. So I would say that's a shortcut, but not always, only if one of the unknowns isolated. I would definitely not use these methods for problems like 17 and so forth. In fact, let me try to do problem number 17 now. Please notice that no x, no y is isolated. So how can I find solution for this system? Well, I guess we would like to eliminate. And I think that a good start will be to notice that x and 4x you can produce with the same coefficients if I multiply by -4 my variable x, because it'll be minus 4x. And of course, I have to multiply by the same -4 entire first equation. In other words, every single entry of my first equation, I multiply by -4. So this becomes minus 4x minus 12y. And this is equal to -20. So this is my first equation. And then I copy second equation the way it is. It's 4x and 5y added with it. And this is equal to 13. So I can add the two equations together and have x canceled. And that's the whole point of this exercises. Eliminate or cancel one of the unknowns. So if I keep adding, this will give us negative 7y, right? And negative 7 will also be on the right side. And notice that's very nice equation because it gives us y is equal to 1 right away, right? Minus 7 times 1 is minus 7. And then I'm going to use my very first equation to find x. Please notice that first equation is convenient to use because when you have just one x in it, it'd be faster to work out. In fact, we usually try to use the equations that have smaller numbers in them. The smaller numbers, the more convenient will be to deal with those equations. So x is found and it is equal to number 2, and we solved another little system. So the point of story is you always look at your variables and ask yourself, which one is more convenient to eliminate? And sometimes it is x, sometimes it is y. What's common with just the first power, that be the result. So elimination method, I guess, is most popular. Notice I don't try to graph or check because that's, well, definitely could be done for fun, but I guess we're not really into doing all that. I just move to the next page and notice there's some more systems here. So I can try another exercise that doesn't look very nicely. For example, problem number 33 does not look very nicely. Why not? Well, if you look closer at problem 33, you may not see which unknown you want to eliminate. Look at this. 2x and 3x, they're definitely not friends of each other. Neither are y's, 3 and 4 y's. So what I can do is eliminate y. The reason I want to eliminate y is because one of them is negative and the other is positive. And the way to eliminate is multiply across. So if I multiply my first equation by 3, so I get 12y. And the second equation, I'll multiply by 4. So I'll also get 12y. And this way, y's will cancel. You see how it goes? So I use 3 to multiply my first equation, and I use 4 everywhere to multiply by my second equation. Well, and then I'm gonna get 9x here, 9x, minus 12 times y, 12y, is equal to 33. So this be my first little equation. And the second equation will be 8x plus 12y. And this is equal to 4 times 4, negative sign is minus 16. So you see what I've done? I produced 12y and minus 12y. And that was my goal, so they cancel each other out when I add those two equations. So the plan is find unknowns with different signs and have them go away by cross-multiplying. Cross-multiplying means if I have 3y, I multiply here by 3, and if I had 4y for the second, I multiply second, for first, I multiply second by 4. Well, and then we continue, then we find that 17x on one side is equal to, look at that, 17. How about that? You had a very nice answer, and that feels right. Well, sometimes you don't have a nice answer. Sometimes the answer could be fraction, which is not a big deal. Fractions also can be worked out. So it looks like here in this system, it doesn't really matter which equation to use. They both are not very nice. So I've just used the first one, for example, and pull out y from it. So from the first equation, when I find y, I'm gonna subtract 3 on both sides of it, just like that, minus 3, right? So we're going to have negative 4y is equal to 8. And this concludes the process. So we get a division by negative 4 on both sides, right? So we get y, which is equal to minus 2, right? Negative times negative is positive, so 2 times 4 is 8. And I have solved another system. Solving systems of equations is the topic of this story. And as I promised, I'm going to move and take a little look at the last section that we want to consider for this class at the section 7.4 with the inequalities that put in the same system. So I guess graphing of inequalities is done here. Let me clean everything I wrote here and stop share this again. And look at a couple of problems that want us to solve inequalities. So for example, if I look at graph and problem 2 here, that talks about graphing line y is equal to negative 2/3 x. So it turns out when you graph this line, you break it. Notice that line y is equal to negative 2/3 x is dashed line. So they broke this line because they don't have equal sign, because y is greater than this negative 2/3. So the point of story is you graph equation first, and then if you don't have equal sign, you put a broken line. And notice they highlighted the region above this line. Why did they do this? Well, because they had so-called test point. They selected point here with coordinates 1 for x and 1 for y. So that'd be clearly point in above region. And then they plugged it in for x and for y. And they wondered, is this true that 1 is greater than negative 2/3 times 1? And they said, yes, it is true. So if it's a yes, then this point is our solution, is in our solution region. So if you said yes, you highlight a region that has that point. If you said no, you would highlight the opposite region on the other side below this line. So that's an idea of solving these inequalities. So let me take a look at another one they have here, just to show you that it's kind of the same thing again. So let's say, how about example 3? Looks like they have inequalities that deal with this verticals and horizontal lines. Like part A here talks about line y is less than or equal to 3. So first of all, you graph line y is equal to 3 with negative sign, negative 3, right? Then you need to select a test point. I like point 0, 0. That's my favorite point, 0, 0. So the point should not be on the line. Like a 0, 0 is a point above the line. And now you plug 0 for y, and you wonder, is 0 less than or equal to negative 3? And the answer is no. 0 is not less, 0 is greater. So if you said no to that point, then you don't include it in your solution. So the part highlighted will be below that line, below the line, not above, but below. So the plan is the same. You graph the line, you see if it's a solid or broken. In my case here, it was solid line because there was equal sign. See, there's equal sign, so it's a solid line. We don't break it. And then I test the point. Point needs not to be on the line. My favorite point is point of origin 0, 0, because zeros are nicest numbers to plug in. So for the second inequality with x is greater than -2, I also graph the borderline x equals to -2 and break it because no equal sign now, right? It's just greater, not greater than or equal, so just strictly greater. And again, I try 0 instead of x because point 0, 0 uses n0 for x and 0 for y. And they wonder, is 0 greater than 2? And the answer is again, no, 0 is not greater than 2. And again, it's no point, so I highlight the opposite direction. So that's really all it is. Once you graph, you need to see what region to select. So in addition to graphing lines, you consider these regions. So let me try to do an exercise here. I think I'll just do a first group of problems, 1 through 22, and that's going to be good enough for our class. So let me clear all the mess produced so far. So share screen again. And I'll just look at the first group of problems. So that'd be the end of homework for you. So you don't have to go any farther than after the exercise 22. So the last thing for homework will be section 7.4, first group of exercises. So you can do a couple of problems here and that'd be good enough. So let me try, let's say, first exercise that says x plus y is greater than or equal to 2. So how I do this? Well, I graph the line. The first thing is going to be the equation rather than inequality. And to graph equation of line, we can use zeros instead of x and 0 instead of y. Right? That'd be convenient. They'd be intersects. So if I use 0 instead of x, I'll get 0 plus y is equal to 2, which actually means that y is 2. So that's convenient. And for the second one, I have x plus y, so it'll be x plus 0 is equal to 2, so x is equal to 2. And then I have the line here that passes through point 2 on y-axis and point 2 on x-axis. So I get these points here and here. And I connect them with a solid line. Right? The line is solid because we do have equal sign. So first step is to graph line. And I think that's our old favorite. We know how to graph lines. And now we have to test and see if we are going to be above or we're going to be below that particular line. And to test it, I'm gonna need to plug this in my inequality. So what do I plug in? 0 for x, and I plug 0 for y. And I wonder, is 0 plus 0 greater than 2 or not? And the answer is no, 0 is not greater than 2. 0 is smaller, right? Okay, so you say no to this point. And if you said no to this point, well, then you go and highlight the other region. So you highlight the part above because this point didn't test. Point 0, 0 did not test. So that's pretty much all one needs to do in these exercises. So let me try one more. Problem number 14, which is pretty similar. In exercise 14, we have another inequality. And to graph it, I need to graph equation first, which is 2x minus 1. And to graph that line, I'd rather use 0 and 1 for x. Why don't I use both zeros for x and y? Well, because it's more convenient to use 1 because y is isolated. Just look at why this is more convenient. So when I use a 0 for x, I find y right away, it's a -1. And notice if I use 1 instead of x, it's also going to be very convenient because I subtract 2 and 1 and I get 1. So when y is on one side, it's better to utilize points such as 0 and 1 for x. But if both x and y are on the same side, then it's better to use zeros for x and for y. But technically, it doesn't really matter because the graph of the line will be the same. So one point is with coordinates 1, 1. The other point is with coordinates 0 and -1, someplace here, right? And again, we have a solid line produced. So the question is, do I need to graph above or below this line? And the answer is I have my favorite test point with coordinates 0 and 0, which is the one above this line, 0.00 is here. And once again, I take my inequality, the original inequality here, and exercise number 14, sorry, not 2, but 14. And I plug in 0 for y and 0 for x. And I wonder, is this right? Yes or no? So like here is yes or no. Is 0 less than -1? And the answer is no, 0 is greater. So once again, we have a no point. And if that's not a point, then I highlight here on the right side. So this is the idea of this entire section. Once you graph your border line, then you need to decide where you highlight. Well, so I guess that should be good enough for our class for this semester. And as I said, there'll be no class on Friday. I know it's disappointing, but well, once we can miss, that's okay. And I will email you practice questions for the final sometime on the weekend. So I will prepare them and check your emails. On Monday, you will get it for sure. And you can just practice the exercise that I will send to you by email. So on Monday morning, so I'll send it to you a little early because Monday morning we have the review, so you should see it before. So let me work on it. I will send it to you earlier. So maybe I'll work on it and send it to you sometime today or tomorrow. So this way you will be able to practice, right? If you feel like it over weekend. And then on Monday morning, when we meet next time, I will definitely work out that exercise and we'll talk about the second problem for the final exam. And the final I administer on Wednesday, not on Friday, but on Wednesday, just to be on the safe side for just in case if something happens, then you just have extra class meeting to make sure that everything is fine. So on Wednesday, there'll be final, and it's also written in the syllabus. It's next week, Wednesday. So homework will also be due, and the homework goes from where we stopped last time all the way to the part that we did, and that's absolutely correct. So that's 5.2 through 7.4, but not entire 7.4, just half, just first half of it, first half of 7.4. So whenever you're done with homework, you can email it to me anytime. You can even send it tonight if you're pretty much done with everything, or tomorrow, or well, anytime before final. Just make sure that you send it to me anytime before final. It's important that you show me your homework because that's part of the grade for this class. Let me check. Do I have homework from everyone? I think I have one person who never submitted me homework, and that's important that you actually send me your homework for the midterm, because otherwise you will lose 10%, we have homework that was 20% of the class and 10% for midterm and another 10% for the final exam. So if you never sent me midterm homework, then you should lose 10% of the grade. So that means the grade is knocked off from A to B or from C to D. So that's definitely no good. So I want to make sure you email me your homework because that's very, very important as a part of grade. And also with respect to the quiz scores, they can definitely be improved if you decide to do some even problems for extra credit. And in this section, you can select any exercise you like, the even side, and do it and get a few extra points. Why not? So I guess that's the message. And that's the idea. So what else we should do? I think we should have a little quiz, maybe our last quiz, right? And that'd be the way to go. So let me give you something to practice on. That'd be, I think, a good idea, right? So I think problem number 2 is a good exercise for a quiz, but I know you cannot graph. So what I'm gonna do is I'm gonna graph for you. So you should graph x minus y is less than or equal to 1. So you need to graph it with equal sign then, right? So you graph so-called border. And again, I'll do the graphing by using zeros for x and y because it'd be convenient because both x and y are on the same side of my equation. So the first says negative y is 1, so y is minus 1. And the second equation says when I put 0 for y, it'll be x minus y is equal to 1, so x is equal to 1. And this gives us a graph of little line. And on y-axis, it's negative 1. On x-axis, it's positive 1. So here's the line. So now the question to you for quiz. Is it above the line or below? Above or below? You need to highlight. So you highlight above the line or below the line. Above the line is up there or below the line is down there. So just write either above or below and don't hurry, just write it only to my name, please. Don't send it to the whole class. So that'd be our little quiz for today. And again, don't hurry, just make sure you give me only one answer, right? So if you say above, below, that means nothing. So you wanna make sure that you say above or you say below, okay? So that's important. So again, please don't be hurry. I'm gonna stop recording.